In this example, we are given three different functions, a, b, and c, and for each part, we want to take the given function and break it down into two different functions which compose together give us that function. So these functions involve multiple operations in a, b, and c, so we should be able to break them down into separate steps. For example, in part A, we're told that the function h of x is equal to 2x plus 1 all raised to the fifth power. And so we want to write this as a composition of two functions, g with f of x. Okay, where here, the way that we're asked to do this, we have f of x is the inside function, and g of x is the outside function. And so we can look at the structure of this function, the expression for this function, for example, and we can see one way to break this down, and there's not a single unique answer here. What it seems to be doing, this function, is it's saying take 2x plus 1 and raise to the fifth power. So this first operation, 2x plus 1, we can think of as the inside function, and this second operation, raised to the fifth power, that could be our outside function, for example. So I could set f of x, the inside function, to be 2x plus 1, and g of x, the outside function, which is raised to the fifth power. And we can check our answer to see if this works. Well, what happens if I compose these functions in that indicated order? So I would take g of f of x. So I would take g of x, which is raised to the fifth power. So I take f of x and raise that to the fifth power. And yes, that would therefore give me 2x plus 1 raised to the fifth power. So that checks out. But notice there's not a unique way to do this. So for example, there are other options. I don't want to list them all, but just to see another example of how you could do this, we could have said what this function says to do is first take a number x and multiply it by 2. And I could set that as my inside function. And then it says we'll take 2x, add 1 to it, and then raise to the fifth power. And you could check that composing functions in this way would say take 2x, add 1 to it, and then raise that to the fifth power. And that also checks out. So the point that I want to make here, there's not a unique way to do this. So there are different answers. These are probably two common ways that you might think about it. So let's take a look at the next example, part B, on the next slide. In part B, we have the function g composed with f of x is equal to 1 over the square root of x squared plus 1. And so again, we have an inside function, f of x, and an outside function, which is denoted with g of x. So it's important that this order does matter. And one way that I could break this down is by taking this function and seeing that first we evaluate the square root of x squared plus 1, then take the reciprocal. And breaking it down into this sequence, we would say the first thing is the inside function, and the last thing that we do is the outside function. And in this case, that would mean f of x is the square root of x squared plus 1, and g of x is take the reciprocal, which is 1 over x. So we've got f of x and g of x. And again, it's a good idea not just to practice composing functions, but to check our answer to compose things in this way. So here I would have 1 over f of x, since the outside function is 1 over x, and then f of x is the square root of x squared plus 1. So that checks out. And again, since we have a whole sequence of operations, there are different ways that we could break up this function into inside and outside functions. So your answers may vary here. Okay, let's move on to the last one, part C, on the next slide. In part C, we now have the function g composed with f of x, which is equal to 2 times the quantity 5 minus x squared, all raised to the third power plus 1. And again, we have an inside function, which is defined as f, and we have an outside function, which is defined as g. And we can break this down into a series of, say, 2 operations, where we can say first evaluate five minus x squared, then plug that result into 2x cubed plus 1. So this over here could be our inside function, and the second thing that we do would be our outside function. So f would be 5 minus x squared if we do things this way, and then g would be 2x cubed plus 1. And we can check to see whether this decomposition works by taking g and plugging f in place of x in the expression for g. That would give us 2, replacing x with 5 minus x squared cubed plus 1. That gives us back the function that we started with. And again, there are many operations here, so there are different ways to say this is going to be our first operation, the inside function, and then the rest of the stuff is going to be our second function. But this is one way that you might break things down.